Hi guys, welcome to Learn Electronics Repair. And these things, again, you're probably sick of seeing these. It's been really an epic, this repair. So many problems with these amplifier boards. And I've been fixing them as I go along. So the last problem I had was that I found this amplifier had faulty Zener diodes. You see the one here? Which is kind of just loose there, and that one there, okay, which is not so loose. The original ones on the board, so this is the good amplifier, is this one and this one, okay. Now, I didn't have any of the correct Zener diodes. I've bought a bag full of them. It was best just to get 100 of them. I have them in stock now. So these are 1.3 watt 16 volt Zeners, okay. And what these Zener diodes do is they regulate the plus and minus 15 or 16 volt supply for the op amps. You can see they've been removed here. There's a transistor, and basically power this part of the circuitry, okay. A quick reminder, why did I remove the other components? Well, I was using the curve tracer and comparing the two PCBs, and I can see that having removed the faulty Zeners, they were definitely faulty, I then fitted these ones, yeah, this one and this one. These are also 16 volts, so the electrical are the same component, but these are only 400 milliwatt dissipation. So I didn't power the amplifier up with these in, I just wanted to make this electrically look the same as that one. I've tagged them on with long wires, and you'll see also both amplifier boards have problems, but this is where the Zener diode is tagged on. You can see the loose trace. Yeah, the trace isn't broken, it's just loose, and that's because the Zener diode isn't actually flat against the PCB. And this PCB, these are very old, they've been running hot for a very, very long time. These things are probably 25 years old, maybe more, okay. And that's why that's waggling around. So I decided I needed to order some Zener diodes and get these things fitted properly. That's one thing. But while I had these things tagged on using the curve tracer again, I could still see there was a difference on the 16 volt supply rail on the two amplifiers. The 16 volts, well, the Zeners regulate it. It actually comes through these power resistors. So the other end of the power resistor is a much higher voltage, 55, 60, something like that. This end is 16 because of the Zener. So if the Zeners failed, it's possible that too much voltage went into the plus 16 volt rail. What does it power? Well, it powers these two op amps, which should fit here, and it powers this transistor. I traced it through, it doesn't go anywhere else. It goes, actually, to tell the truth, through a high value resistor to somewhere else in the board, but due to the resistor value, not much current could flow that way. So the most likely thing to be damaged is the op amps by the higher voltage because of the Zener failing, if that's what has actually happened, yeah. The Zeners weren't short, they just had funny readings, so I expect probably the voltage rail did go too high, and these op amps can handle plus and minus 20 volts. That's what the data sheet says. So if it goes up to like plus and minus 50, which it could if the Zener wasn't working properly, then they could easily be damaged. The other thing, it goes to this transistor, that could be damaged. So I removed the op amps, I removed the transistor, and they still look different. And eventually I traced it to this capacitor. So this capacitor is on the plus 16 volt rail, okay. Both capacitors I removed, and the PCBs then looked the same. So the curve tracer now tells me on that voltage rail they look the same, yeah. Both capacitors were actually bad. One was really bad and the other one was bad, yeah. So one was worse than the other, but both of them were bad. And I'm thinking now that although they both look the same to the curve tracer, it's very likely that we have a lot of bad capacitors on here. Again, because this thing is 20 years or more old, 20 to 30 years old probably, and because these things run hot and these amplifiers are used for long periods of time, it's likely that all the capacitors are bad. Even though this one is working, it was a little bit distorted, to be quite honest, and that again could just be down to these bad capacitors. Yeah, so if we look at the whole board, we can see we have 2, 3, 4, 5, 6, 7 capacitors in this area, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have 17 capacitors on each board, and I think I need to remove all of them. I can test them, but I think I'm just going to replace them with new ones. But we can have a look just to see how they read. Yeah, I think I need to do all that. I need to figure out if these op amps I've removed are any good, although I do have replacements anyway. And I need to figure out if that transistor is any good. I can use a component tester to do that. Okay, so first of all, the op amps, and you can see this because it came into shot. This is the ominous op amp tester. Okay, these are the op amps I removed. The ones with the white mark on them are from the amplifier that effectively powered up but gave no audio. These two are from the amplifier that worked but was a little bit distorted. I'll just add, by the way, after I found the distortion, I found a broken track on the amplifier which was distorted, so that may actually be what did cause it. But let's see. So 9 volts in, voltage regulator, this sets the test current. So we just put the op amp into the socket for a single op amp, and the LED here, this should flash if it's good, like so. So that tells me this is a good op amp. It doesn't test every feature of it, but it does tell me it works. It could still have some strange problem. That's one of the ones out of the amplifier with no audio. This one is bad. Okay, doesn't flash the LED. That's bad. So that's another good reason why that amplifier had no audio. Okay, this one is good, and this one is also good. Okay, so we have 3 good ones, one bad one. So the 2 which are good, these are from the amplifier that did basically work. I'm going to put these back on there. Okay, the 2 that one reads bad, one reads good, I'm going to replace them both. And I actually bought some. I have 10 of them, TL071. So let's just test a couple of these as well, although these are new. Well, actually that one doesn't work. Interesting. These came from AliExpress, by the way. Well, doesn't work. Try another one. Doesn't work. This is interesting because none of these appear to actually work. From what I can see. We know the tester works. No. Well, I don't have many left, do I? But none of these appear to work. TL071s. No, I have a whole batch there. None of them are working. Okay, 10 of them. Is there anything different about these? TL071CP as opposed to, no, TL071CP. The same. And that's the good one. Oh, interestingly, now actually they both work. Maybe I had a bad connection on that one before. Okay, so they both do actually work. Strange. Yes. Yes. At this point you start to doubt the tester, don't you? But definitely don't work. Anybody suggest on the live stream this Sunday another way we could test those maybe? As to why these are not actually functioning in here, I'd be interested to hear. Well, we can put the 4 back in. That's the first thing. These are the transistors. So BC557B, BC557. This came from the good amplifier. This with the white mark, the bad. This also has like a silver side on it. It seems to be different from all of the other ones on the board, making me think this has been changed previously by somebody. So this one, yeah, it's good. And the other one, yeah, also reads good, and very similar gain to each other actually. Okay, so those can go back in, those can go back in, these can go in, and then let's have a look at these capacitors. I'll just check these Zener diodes while I'm at it, so push the button. Yeah, it regulates at 15 volts, like you see, it doesn't go any higher than I'm just turning the thing up, but it stops there. Okay, so 15.4. And this one, $15.9, and then I can continue to turn the voltage up, but it stops. Okay. Right. So the fact I now have the diode flush with the board, pretty much it should stop this thing where it was kind of waggling around and moving the tracks about. Okay. I'll try and get the track pushed back against the board as best I can as well. See, like so. And then I'll solder it down there. This is where I put the other bit of wire in to repair this track anyway, so we have that also. Okay. Yeah, that's soldered fine. Okay, and then the other one again, I managed to get the track pretty much flush to the board. Okay, let's solder that one. And that just stopped that waggling around as well. I'll just give that a nice rounded top. Yeah, I've cut it same as this one. Okay. Other Zener. I think you could reasonably argue this is actually a restoration job. I'm not totally convinced I'm easily going to get the leg of the opponent to come through here. No, it doesn't look very good, that at all. In fact, I think the track actually came off now. Yeah, okay, so we're going to have to repair that bit of PCB as well. Let's clean that up and take a look. I think that's actually an interesting question, really, is where does repair end and where does restoration start? I mean, technically speaking, they're both the same thing. Sure, you guys would have some comments about that, yeah. Where would you draw the line between repair and restoration, and why? What's the reasoning? I mean, does repair become restoration when you have multiple faults like this? Is it really restoration when it's not particularly economical to fix it, but you do it anyway? Is restoration more a labour of love? Perhaps restoration is more something you do for something that you own, yeah, like a classic car or steam engine or whatever you're into, yeah. Don't worry about these missing pads, by the way, they're not connected to anything. If you look at the data sheet, they don't actually connect to anything, yeah. That's why they fell off in actual fact, because they weren't connected to anything, they're just pads. Okay, so that's what we have. This is where that last track came off. Let me just get rid of it off the board, and we can see the actual remnants of the track there as well, which goes up there. Okay, I would actually cut that off because you don't want it like moving and shorting something, so let's just get rid of that. Okay, and we can see where I've bent over the leg there of the diode compared to the other one, which is here, which goes to there, so that's fine. So that's all the parts either replaced or refitted. Let's look at these capacitors. Let's see what we have. So C1 and C2. I'm interested to see if these are all basically the same value. 2.200 volt, 2.200 volt. A lot of these small capacitors, 2.2100, which is the same as the one I actually removed. No, it's not. That's 4.763. Then we have these larger ones. What are these? 1016, 1016. Some more bigger ones here. 22050s. So we have quite a variety of different values here actually. Some more. They're also 22050. And then a little group at the top, so 47025, 2.200 again, another 4.750 this time, 4.750, these three, 4.750, same, and same. So there's just a few different values actually. All the capacitors are actually marked on here with numbers, and they're also marked with the positive end as well. You can see there like a plus sign and a flat bit on the silk screening. Okay, so I don't need to make a note of the polarities, but if I make a note of the values against the component number, I'll just remove all of them from both boards then, and let's see what we have. Okay, so not quite in order because I missed those two, but that's what we actually have. So we have the 2.2s, we have the 4.7s, the 1000s, the 220s, we have some 470 and 47s. Yeah, so a handful of values there, mainly high voltage capacitors actually, apart from those, or relatively high voltage. I'll make a white mark on all the capacitors from the bad board, and I'm going to remove all of them from both. And then, in fact, maybe I'd make a red mark, a bit more visible. Yeah, so I know which ones came from this amplifier. I'll take all of them off, and then let's have a see what we have. Also, just before I unsolder these, I noticed that these two appear to have leaked out everywhere, unless that is glue. But on the non-working board, I don't see that, so there's either just glue on one or the fact that the other ones have leaked. Okay, so I removed all those capacitors, and while I was doing that, I asked myself, why am I removing all the capacitors from these boards when I would argue, and in fact I'm sure I have argued, that that isn't proper fault finding. Just changing all the capacitors, this is not fault finding. This is like, you know, sticking your finger in the air and saying it's blowing that way. Yeah. So why? Well, I think, in fact, I'm sure because I've done it, there are some factors here. So one is the age of these boards, and I know the environment these are used in. I know they're used in high temperatures outdoors here. Yeah, it's pretty much always, well, here it's either hot or very hot. Yeah, on the rare occasion it's warm. Okay, so there's that, and the other factors, the age of them. But it's mainly down to the fact that when I took those other capacitors off to see where the difference was, even the one from the good channel wasn't a good capacitor. It was better than the other one, but it wasn't good. Yeah. So let's have a look. Let's see what we have. Let's see if I was right. These are the 1000 microfarad 16 volts. Okay, what do we have? Yeah, that's pretty good. That's off the bad amplifier. I mean, it's close enough to be within tolerance. That one, now that's interesting because that reads, you see that? It went over. Let's just try it again. No, I must have just slipped with the leads. Okay, so about the same as each other, not particularly bad. Two more of them, 1016, same as those ones. This one. Yeah. I would say they all read okay, but I'm pretty sure I'll just change them anyway while we're here. 470/25s. How do these read? That reads okay. I mean, these are old capacitors, yeah, but that reads okay. This is off the bad one. This has like that bit of discoloration underneath it. Okay, you see that? Let's have a look. It reads pretty much okay, yeah, within tolerance. 220 50 volt. I think we have a few of these. Yeah. Uh-huh. Yeah, we have 6 of them. Okay, 220 50s. Reads okay. Reads okay. Yeah. Yep. Yeah. Yeah, all read okay. Okay, these are all 47 microfarad 50 volt. Reads 52. Like the same. Yeah. Yeah, these are all reading good. Okay. These ones are all 2.2 microfarad 100 volt. Let's go down the range as well. 2.2. 2.2. 2.2. Reading good so far. That one reads a little bit lower. I wouldn't say it was out of spec because the tolerance on these isn't very close. But it is notably different from the others. And that one. Okay, so 2 red, pretty much different from the others. Interesting ones off the bad, ones off the good. So it's probably something to do with the position in the circuit. And these are the 4.7s. There are 4, I have 3 of them. I think I threw the one away that was the actually bad one, yeah, or the worst one. Well, that means 2.8, and that should be a 4.7. Yeah, that is out of spec. That reads way over. Now, when you see this happening, and I'll just show you the capacitor. So again, this is a 4.7. Yeah. Well, now it reads very low. Sometimes it'll read much higher than it should. Like that's just done again. Can you see that? If you get them reading much higher than they should, they're bad. You'll find that the ESR is much lower than normal, but the leakage is very high. So that's a bad capacitor. This one is bad enough. Okay, so those are effectively the same value as the one I found before that I've been. Now it was even worse. All these read okay, and these ones read okay apart from 2 of them which don't. Okay, so we do have some bad capacitors on here. Now, to find those via fault finding in this instance, given the history of this, I think is likely to be more difficult than the way I've done it. Yeah, interesting, of course, as always, to know what you guys think down there. If I have replacements for these, I'll probably just change them all anyway now I'm here. But otherwise, I'd be confident enough about putting those back on. I noticed I missed a few actually. I hadn't unsoldered, so let's have a quick look as well of those. So here's another 4.763 from the bad board. That's definitely bad. And these are the other 22050s that were stuck down. Is it glue? Is it out of the capacitor? Let's see how they read. Well, it reads okay. Sorry you can't see it. You probably didn't see the other one either. Believe me, the other one was bad. Okay, that reads okay. And the other one that was stuck down. So this was probably glue actually. Reads okay. Go on, here's the bad one you couldn't see. Yeah, it's bad. Okay, so I've replaced most of the capacitors. What I don't have, or anything even like, are the 2.2 microfarad 100 volt capacitors. And a few of those read not good. Most of them read okay, although I wouldn't totally trust them, especially when they get hot. But those are the ones I don't have. Everything else I had exact replacements for, brand new. And this goes to show you have 2 big tubs full of new electrolytic capacitors and quite a lot of poles. Sometimes you don't have everything. So I'm going to order those. I need 8. I'll get like 20 or something, whatever they come in. So I have some spare for future use. And then I think we can finish this job off. So what we'll do on the next one, I'll replace those, and let's see if we can figure out whether we can power this up from our bench power supply rather than using the actual power supply built into it. This could be useful in 2 ways. One, we can set a current limit, and secondly, we can also see whether the amplifier is drawing basically the same amount of current off the positive and negative rails. Yeah, that might be an interesting thing to see. I'll order some more of these TL07 ones as well. It seems very strange that those 10 are all bad or fake. I mean, it doesn't seem like the sort of rare or hard to find or expensive component that would even be worth faking. Yeah, so any ideas on that? Live stream on Sunday, let's talk about it. We can always have another look at those. So final part of this, yeah, we're getting somewhere. Is it restoration or is it a repair? And would you have changed all those capacitors or not? And is that really fault finding? Lots of things to talk about down there. Look forward to hearing from you soon, and of course seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.